Hello, this is Mr. Huff, and I want to talk a little bit about how we're going to document programs. Instead of using flowcharts, we're going to use pseudocode. And to understand this, you need to understand behavior-based programming. And this slide has a lot of information on it. This is also in the curriculum. You can download this in the machine control folder. This is programming by design or something like that. So what you're going to do is think about complex behaviors, which are kind of like an overall description of what is happening. Simple behaviors where you break the into individual tasks, and then basic behaviors. These are single line commands for the robot. So, or to your program. So I like this little sentence at the bottom. Complex behaviors are broken down into simple behaviors, which are broken down into basic behaviors. So really that's what we're after. We're trying to take our program, describe what it does, break it down into simple behaviors, and break those down into very basic behaviors where we can turn that into code, writing one line at a time. All right, and then they have an example here. Let's look at that. So it says, that you're going to describe a task or overall goal that a program will accomplish. So it's going to run a fan until someone needs it to stop, and it's going to have a safety device warning light that turns on before a fan turns on. Another light indicates that a fan is stopped. So those are the behaviors that you're looking for. And this can be described as one or more complex behaviors. So you need to break that down into pseudocodes. You're taking those individual, the behaviors, and breaking it down into actions. Okay, this is important. The second sentence here, do not be concerned about syntax, which robot commands will be used with ROBOTC. You need to stick to the actions, so nouns and verbs, what it's actually going to do. Don't worry about syntax. So it needs to describe it. Don't put code in as actual code in as pseudocode. Pseudocode is a description, okay? So you describe what they're going to do, like turn a motor on for 3 seconds, wait, follow a line until it runs into a wall, do this until someone pushes a button or something like that, okay? For simple behaviors, you're going to break your complex behaviors down into simple things, and the simple things get broken down into the basic actions. So this is where you this is where you need to pay attention to sequence. So think about what has to happen first, and then next, and finally. So that's where your documentation this way is going to help you solve problems before they happen, is if you think about order before you do anything. Okay. So these are other examples of pseudocode here. That's interesting. Moving on. And then for basic behaviors, once you get your simple behavior down, then you're breaking it down into individual steps about making that happen. So write in terms of the input and output relative to each device by line is what you're doing. So that's kind of how it goes. So we're going to look at an example here in just a moment. This would be an example of some pseudocode. So the program is going to start. It's going to turn a light on for 3 seconds. It's going to turn a motor on until a button is pressed, and then it's going to run a light for 3 seconds, and then the program ends. Okay, so that's what it's going to do. That is an example of pseudocode. It tells you what the program's going to do without actually putting in code. So before you can do this, or as you're converting your pseudocode into actual code, you need to understand where your motors are, what your inputs are, what kind of inputs are there, and what their names are. So you need to make sure you have a list of what's happening on your cortex and where things are. Let's see, and we're going to be using the PLTW template for this activity. So we'll always start with that, and you'll always fill in the header with your name and that sort of thing. It's pretty self-explanatory. So I should see something like this. So right here we have the header. So I would expect to see a project title, who's working on it, what's the date, what's a section I don't really care about. A task description, this is what your program is for. And then I would expect to see pseudocode listed like this. And then inside your program, this is where task main starts. You would make individual line comments for every part of the program. So right here where your program begins and light 1, LED 1 turns on, I would expect to see your program start commands here. I would expect to see in between these two, or after this, I would actually want this on one line. So in between turning the light on and turning the motor on, I would expect to see your code for the light right here, and then after that, the code for the motor, after that, the code for the button, after this, the code for the light, and then down here, the end of the program. So the other thing, and it goes through a lot of the program design here, and it talks about how the code is written. I'm not really interested in that right now. You're going to do that on your own. And it kind of talks about what each little part is. I also need to talk about formatting and that sort of thing, because if you're not straightforward on your formatting, it makes it really hard to troubleshoot your code. Really what I'm after is where they do the line comments. So this is what I want to see. For every line, I would like to see where program begins, that needs to be left justified above your code. And then every line needs to have a comment explaining what it's doing. So right here we have, this turns on LED 1. This is making it wait for 3 seconds. I would like to see something a little more verbose here. The light is on for 3 seconds or something like that. And then LED 1 turns off. So I would like to see a description for every line of code along with the pseudocode. Let's look what else it has here. So, okay, and then it gets into some specifics about doing different things. Let's go through and look at this code a little more. Actually, I think I'm going to pause and show you some code. So this is an example of some code that was written in ROBOTC. It's not in ROBOTC right now. I'm using a text editor to show this, which has some context highlighting. But you can see some things here. So this is a section of code right here that has been commented out. It was something that was being referred to in their original design of their program, but they made it all comments because it's not useful anymore. But it's still there if they need to put it back. So this is something that programmers do a lot. Okay, notice right here, this would be the pseudocode right here. So this says right sensor sees dark and center does not. Right sensor sees dark and center does as well. Then you have these other things, counter steer right, sensor sees dark. That's examples of pseudocode. And then also I want the basic commands also identified. So for each line right here, we have a motor identified as left motor is going 25 for the motor speed, and then the motor on the right motor is going negative 25, and this is for a slow turn. So what you've done here is explained what this specific command is doing in relation to this pseudocode description. So we've described the kind of the simple function, and then we've got the basic command described in each one. So this is what I'm looking for when you do your code, pseudocode. We're not going to use flowcharts. We're going to use pseudocode. One of the big things I'll see is you guys will jump in and start programming without doing any pseudocode because it's in your head and it won't work. And I'll look at your program and I'll say, where's your pseudocode? And as you go through and start adding that in, you'll find logical errors that should have been avoided. So make sure that you are doing your pseudocode first before you start writing. You should have an idea of the process flow of your code. So I'll go over this more in class, but this is just an introduction for how to do pseudocode.